We're recording, so we can obviously post these for all of our students that aren't here. All one of our students that aren't here.
Before we start, is there any questions that you need to pose? We can ask certain questions. You can think of
Ask about this. What's micro? What's division? What's that R in the top right corner?
What's so crucial about your PowerPoint?
Okay, let's get going. We're all ready. We are recording.
I am Peyton Harrison, a person from Crucial Technology, which is a division from Micron Technology. Why I'm here to present a memory for business motherboard, and I'm doing the fastest, and memory for a gamer motherboard with the cheapest one. About us. Crucial Technology is a brand name used by Micron Technology Incorporated. Micron Technology is an American multinational corporation based in Boise, Idaho, best known for producing many forms of semiconductor devices, which includes DRAM, SDRAM, flash memory, and SSDs. And that is Crucial, which is mainly used. Micron does a lot more than that. Our income report over the last year. This is the last quarter since 2013, and then 2014 up till now. You can see we're growing.
I'm sorry, go back one. I was distracted by the person that
Our income report over the last
It's in,
year.
what are our reference? What is that?
This is the revenue.
So they only made $5,000, or is that?
No, that's in millions.
Okay, see, that's what you're saying. It's our reference for those.
Sorry.
So it's 5,000 million,
Well,
or
I don't know.
which would be 5 billion, right? So that's or is that? I mean, I don't know. I don't know Micron. You didn't. You work for them, so that's why I'm kind of curious.
Yes, it's in millions, but I can't tell you why it's thousands.
Well, I mean, if it's in millions, that could be 5 billion.
Yeah.
They could have made $4
I think that is
billion,
revenue,
but,
and then
you know, when you have a chart, you might always want to put on your thing the key to the chart. So
Okay, I'll be honest, I
It's
cannot
not. I
find
mean,
any
5. This is 6
figures
RAM.
to-
I don't know.
This is just some random chart.
This is the actual chart from
I found this
my
somewhere.
year.
Liked it. Don't know what it means, but.
Our headquarters, Micron headquarters, is located in Boise, Idaho. Here's this. And Crucial is a
Crucial's a
part of
division of
Micron.
Micron. Does Micron make PCs anymore? Our whole school used to be filled with Micron PCs at one point. Because the Air Force used to buy them, so we got them from the Air Force. And I haven't seen a Micron PC for years.
I know, just
So when you did your research, you don't know if they make PCs?
Well,
I work for them and you're not sure.
I work for Crucial.
Oh, okay.
I work for Crucial, which is part of
You just
Micron.
thought you'd put up a Micron slide and know nothing about it. Go ahead. Just give me a hard
And
time.
Boise, Idaho is located there.
In
Nowhere.
Do they have a sign?
Idaho.
Are they Packer fans in Idaho? Are they upset by the recent playoff game? Because I am.
I'm fucking.
They should have won that game. They gave up with 4 minutes left. And we're just trying to burn time. They should have been trying for another touchdown, and that wouldn't have happened.
I was watching. Alright, this is my business motherboard. It is DDR3 DIMM socket supporting up to 32 gigabytes of system memory. It supports 1600 or 1300 megahertz of memory, and it's a dual channel memory architecture motherboard.
Okay, so what generation is the memory that this motherboard supports?
It'd be the
is it first generation, second generation, what generation? Just,
Second, I don't.
anyone else?
Third.
Third generation, why is it third
Because
generation?
DDR3.
Because it's DDR3.
I was about to say that.
Ah, but you didn't.
That's true. But like 15, 3. This is my first memory. Don't get confused, it's only one. I just have two pictures for this one that's kind of blurry.
Just in case we wanted to see what it looks like on the side.
That's the Crucial Ballistics Elite 4 GB DDR3 SD RAM. Speed is DDR3 1600, which is a PC3, so generation 3. Access time, this is what I found. I'll be honest, I don't know what it means.
Okay, so that is the timing, but I was actually asking for it in nanoseconds. And I will show you how to do that.
Bandwidth.
Because the only true way to compare memory is through actually calculated access time. I'm going to show you that at the end of all 4 presentations. Oh, wait, I have to move 2 presentations.
Bandwidth, the 4 GB capacity, it's non-parity, non-ECC, it's dual channel capability, voltage is 1.5 volts, cast latency of 8, and it's a 240 pin DDR3 SD RAM, contact type is gold. Price is $44.99.
How much did you say? $44.99?
This is on the
So it's $44.99 for one 4 gig stick
yes.
for a business phone. Okay. Was it because you went with the fastest? Is there a reason you didn't look at 2 gig sticks instead of
Because
one?
when I went to find 2 gig, it was a lot more expensive. Like if I would buy 2 gig. Like I found some 1 gigs of 2 that were a lot cheaper than this, but I could not find any cheaper.
But you weren't going for cheap, you were going fast. Right?
Yes.
So my point is that if you're going for cheap, 1 stick is fine. But if you're going for fast, actually, if you found the same stick that's a 2 by 2, let's say everything else being the same, the 2 by 2 would be faster for your PC because then it would take advantage of the fact that you're buying dual channel RAM and it'll make your system go faster. 2 gigs is faster than 1 4 gig.
On Newegg, I could not find any 2 gig that supported 1600.
Okay, I'm not saying you couldn't. I just wanted to make sure you understood that.
Because you were helping me.
Austin's like, I'm not on this bus. Don't roll me under it. No, I just want to make sure you guys understand because you're going to get that question on your test. Which one is faster? And I'm going to give you the exact same memory. And someone always picks the 4 gig because it's more. More is not faster. Dual channel, if you got a dual channel or quad channel motherboard, and you put dual or quad or tri memory that takes advantage of that, then it's going to make your system faster. Now, if I just put 1 stick in and 1 stick in, it's the same speed. But if I'm going 2 2s versus 1 4, it's faster. Just wanted to make sure I spec the horse a couple times and make sure.
Do you want to see some speech?
Nope. Nope, we gotta go fast to get through all 4 of these things. I'm just kidding. You've got lots of time.
Any questions?
You said it was gold contacts. Did anyone here, not just for you, did anybody here see 10 contacts at all on their memory? I don't know if they still do. I mean, it's been a couple years since I've actually had anyone present with 10 contacts. I don't know if the speed of the RAM is such that anymore that 10 won't even support it. Maybe the contact isn't good enough for it to
What
support
is,
it.
like, why does it matter?
Gold are much better contacts. The information or the data transfers much faster, it's much more reliable. If you're buying audio-visual cables and they say gold connectors, it means that it's going to connect in. And gold actually is the best transmitter of electricity. It's just kind
Why
of
does it
expensive.
make 10 up? It's more expensive.
Yeah.
Like the motherboards and apps, others that have
Yep. And that's why motherboards also are faster now, because they're using more gold in them, which is why they pay us to recycle, because they melt them down, I'm sure, get one drop. I mean, it's so fine, they get more like one drop of gold out of that whole motherboard probably. You get something, it's worth their time.
Alright, my gamer motherboard is a DDR3 Intel supporting up to 32 gigabytes of system memory. It supports all of these in 1633. I ended up pulling 1800. And it's a dual channel memory architecture.
Okay, so it's got 4 slots, so each slot only takes 3 gigs.
Crystal Ballistics Tactical Tracer 8 gigabyte. It's 2 4 gigabytes, so it's 2 sticks.
And we're looking at the cheapest for your gamer right now, right?
It was cheapest to buy 2 4 than just 1 on the way. I didn't check it. Speed is DDR3. Oh, it's 16 generation 3 access time. And my bandwidth is 8 gigabyte capacity. It's non-parity, non-ECC. It's dual channel creative architecture. Fast latency of 8, voltage of 1.5. This for each of them. And then it's 240 pin DDR3 SD RAM, and it's global bus.
That's pretty good, because if your 4 was $44.99, it was $19.99.
Well, I actually found, now that you said, I should have just gone with, but I did find 2 4 sticks of what I had on for my business motherboard, and so I could have gone with that.
Yeah, but you can't present the
can't
same
present the
thing,
same
right?
ones. It was actually cheaper. Just in the next one.
Is it the same speed, or are they both DDR 1600?
I'd go for the specification.
Yep, that's okay. We need to give 2 of these people a little extra free time to work on their presentations for the class today.
Any questions after?
It's a good thing you did screen captures, because we had somebody today whose memory could have like double. They had 119 on their slide, did not have a screen capture, and it was 239. The only thing that saved them is when we went all the way down to the bottom of their page, it showed that they were sold out of the 119. So we're still able to back up the 119. That's why we do the screen capture.
Which, why is it so long?
I don't know, somebody else had that too.
Both of my
the title, but you can edit those. You can hit delete, because really, after you get to the Crucial Ballistic Tactical Tracer 8 2x4, boom, right there, that's good enough. You don't have to have all the rest of it. It's like they've got the whole spec. Well, I know, I mean down to there, and then all of a sudden where it says desktop area,
I think what it did in the rule, like it is, it takes your article title and multiplies it by like 5.
Yeah, some of it there is like it's double.
It's like 60.
Right.
I
Yeah,
don't know
and
why
then
it did that.
somebody else is supporting the same thing.
This is both my memory, so.
Yeah, so feel free to edit that a little bit when you see that it's, I don't
See,
know.
I do it
It's
on
probably
YouTube, and then
because
I
it's
just
there
export
but
it.
hidden for search engines. Because the more times it appears on the page, the more likely it is to be caught by a search engine. So they probably have it as hidden text in there, and then EasyBib, just because it's hidden white on white doesn't mean EasyBib doesn't see it, and all of a sudden EasyBib pulls it all in. It's there.
You see, like, that's never happened to me before. Like, it's usually just shorter.
Yeah, it must be something Newegg's doing to try to increase where they're at on the search engines. Any questions for Mr. Harrison? Let's go to Mr. No Lines on My Paper Green. Hold that up while I shut this out. Actually, we're going to take a 1-minute break. We'll let Kingston.
Of course.
Oh, he did. they need to put the name on it.
Which, what is it, Laura?
True.
What is component?
What is
Okay.
green?
Reasons to buy.
We're ready, Mr. Green. Anybody else, I mean, did you guys have problems other than access time? We're just gonna talk about how to calculate that. Finding stuff, or are we just kinda?
No.
I didn't know what contact.
Too much
type
brightness?
was.
In the beginning, like, we all had problems.
Yeah.
And then,
Well,
like,
because
towards the end,
we
we
were
figured
really-
most
the
of
thing
it
that
out.
confused us most was, we were confused, like, cause like my business on the board took up to, I think, 32 gigabytes, and I was doing the best, and so I didn't understand why I couldn't go over 4 gigabytes.
Because really you wouldn't.
Okay.
I mean, because normal, like just like we have at Trail, we use 32-bit processors, we use a 32-bit operating system, which means it can't see more than 4K. So just because you can put 32 in it, if you put 32 in it, put Windows 7 32-bit on it, we would see 4. That's all it would see. So like the version that you have right there, we could put 8 gig in that laptop, we would see 4. So what would we be wasting the other 4 gig for? Nothing. So that's why on a normal business, and that's because normal business applications, none of them require 64-bit computing at all. So, in fact, the Air Force just went to 64-bit. The computer I have at my desk is phenomenal. It's really nice. Complete waste of money. What do we use it? We use it for Internet Explorer and Office. It's the only thing installed on the whole computer. Why do I mean, I've got a server. I got a server at my desk. It's at 8 gig RAM. It's Windows 7, Windows 7 64-bit. It's got a 1 terabyte hard drive, of which 995 terabytes are free. I mean, it's ridiculous. I mean, gig or free. It's ridiculous. There's nothing on it. It's got Windows 7. You have more on that laptop, on the 60 gig drive, than I have on my desktop, the Air Force, on a 1 terabyte drive. It's overkill. There's no reason to spend that money. And by the way, a 1 terabyte drive is slower because it's bigger and stuff doesn't all get put together. So when you get a huge drive that you don't use, you're making your system slower. It's better to have it, I'm not saying get the smallest drive you can, but sometimes people are silly. So anyway, that's why. But on your gamer, you would put 64-bit, so you would put 8 to 16 on it. I put 32 on mine at home, doesn't do anything over 16. Nothing. You can't see one iota of difference. I never go to the upper level memory unless I'm making virtual servers for school, which is why I have it on in the first place. And then I can have a server and 2 or 3 workstations running inside my PC.
Alright, well.
Sorry,
Hi,
We're ready.
I'm Austin, and I'm here from Corsair Components. Our company, we were founded in 1994 with the name Corsair Memory Incorporated. We originally developed L2 cache modules for OEMs after Intel's release.
Didn't you just do Corsair?
No, I did.
Crucial. Okay, sorry.
With incorporated L2 cache, we moved on to DRAM modules, primarily for servers, and in November of 2010, our company changed its name to Corsair. Today, however, our company makes some of the finest memory and power supplies in the world, and we sell many other top-end gaming accessories such as mice and headquarters. We're headquarters are located in Bayside Parkway, Fremont, California.
Fancy building, I like your sign.
Yeah, we need looking nice on the side. I feel like
It doesn't look like you bartered it.
For the year, the end of December 31st, 2011, we generated a net revenue of $455.2 million, gross profit of $74.4 million, net income of $19.4 million, and adjusted net income of $60.7 million. 3 months ended March 31st, 2012, we generated net revenues of $32.6 million, gross profit of $20.3 million, net income of $3.1 million, adjusted net income of $3.9 million. And there's other financial stuff on like NASDAQ. I'm here to show you the best memory for a home PC and the cheapest memory for a business PC. Home PC, we have the ECS H61, H2, LG, and LP5. HDMI micro RTX. 2 240p DDR3 DIMM sockets. Supports DDR3, 16 converters to 233 and 266, and 60 megabytes of RAM. So I go with the Corsair XMS3 2GB 240 pins RAM. DDR3 1333. Carry capacity of RAM with the 2 gigabytes, DDR3 1333 SD RAM, capacity CF9, single channel memory, it's non-parity and non-ECC.
your best is only $34.99. Okay.
Yeah. Well, to be honest, though, I'm not complaining. I have much to choose from.
All of them first block did that too. So $34.99 for a 2 gig stick for a phone. That's more expensive.
He really didn't have much to choose from.
I had like two to $3.94.
For his home.
Yeah. So they make like DDR4 memory now, so they're not really so much DDR3 memories now.
Well, 90% of motherboards today are still being made with
Yeah.
DDR3. There's so few DDR4. In fact, I had to make somebody first block code show me the motherboard specs because I didn't remember it was only like to DDR4. It did. So I had to game a motherboard to DDR4 first block.
For our business, we use the B85H3M7, 1150 socket. There's our motherboard. We got two 240-pin DIMM sockets, accepts DDR3, 16 3, 266. Dual channel and it supports 16 gigabytes of memory. So I'm with the Corsair 48 240-pin DDR3 SD RAM. It's not memory module. It's got a capacity bandwidth of 4 gigs.
How long has it been sitting out
Yeah, I
there?
don't know.
3 years done?
Yeah, it's not most managed in borrowers.
Borrow a mouse?
Yes. It's all done with most of it. Just gonna give me.
Hurry up.
I've also presented.
Capacity or bandwidth of 4 gigabytes, DDR3 SD RAM, fast latency is 9, single channel memory, 9 parity 1 ECC, lower context, timing of
$39.99? So you paid $34 for 2 and now $39 for 4.
Wait, what were you doing again? The cheapest?
Yeah, cheapest business and then fastest.com.
So is this slower than the other one? The other one was 1600 one year. This 1333.
No, I think they were both 1333. I think this one's just 4 gig, that's the only difference.
But it's only $4 more. $5 more.
I'm pretty sure it's like the only difference between the two. Yeah, they're both 1333. This one's 2 gig, one's 4 gig.
Okay.
The cheapest.
So yeah, this is just to make my cheap look cheaper. Did I say you could leave that page? I just
Looks like 3 characters.
Where's our questions page? Do we have
Yeah.
questions?
I have, just asking.
I didn't see.
I'm open for
I
any
didn't see a
questions.
Okay, so what I want to talk about, and then I'm going to give you guys time to finish your presentation, which you'll have to do during the intervention. Now, thank you very much. Is to talk about access time and comparing memory speeds, which is really what access time is about. Okay, so we've got our timing on here. Like, let's look at Austin's right here. We've got the timing on here, right? We've got that it's 1333 and timing at 999, and the first one is our cast latency. And let's, first of all, what is cast latency again?
How many times per respond?
Okay, how many cycles of the motherboard it
Is that
takes
why-
to read and write to this memory?
Is that why
Okay?
my cast latency was 8, my timing was 88824?
Yes, the first one's always the cast latency number per your reading that I'm sure you all read. Okay, so, and cast latency is a way to compare, just like this is a way to compare, okay? So it's that this memory is going at 1333 megahertz, and it takes, which is 1333 cycles per second, and then the cast latency timing, meaning it's going to take 9 cycles to do it. And I've got a couple, let's see if I can find one, there we go. A couple just to kind of show you how to calculate access time, because it's not out there anymore, and I'm going to use this one as an example, okay? So this is DDR3 1600, okay? So it cycles at 1,600 million, okay? That's megahertz, right? That's in megahertz, which is millions of cycles per second, okay? So what we want to do is turn it into how many seconds does it take? So we divide it, so what we do is we go and say 1 over 160,000,000 to find out how fast a cycle is. And we're going to have that come out in nanoseconds so that we can do some math. Okay? So if that's how much time it takes for one cycle, then we would multiply that by 9. Which equals a time in nanoseconds to access it. Okay? Because this doesn't give us a time, this is just cycles. And this doesn't give us a time, it's just speed. Okay? So we need to turn it into a time. So you would take 1 over this times this, gives us some kind of time that it would be to access it. Okay? So I would take, just with my calculator, and I would take, I'm gonna make it easy and not do all the zeros. So I'm gonna do 1 over 1600 times 9, and I'm gonna come out with 5.6 5.6 nanoseconds is how long it takes to access memory on that stick. Okay, that's how long it takes, okay? So giving this as our equation and how we figure out access time, what I want to get is this, okay? And I want to look at this one. Oh, it's not on anymore. There we go. I want to look at this one and talk about, is one stick faster than the other, okay? So I've got this one, and when people look at it, they're going to say, okay, it's 1866 and it got a cast latency of 10. This one is 2400. Okay, so if all I look at is the megahertz, that's all I look at. This one's definitely faster than this one, but our cast latency is different. This is a cast latency of 10, and this is a cast latency of 13. So when we go to buy, everybody goes and says, this one's faster, it's 2400 than this one that's 1866. Nobody looks at this, and if you do, well, it's only 3 different. Okay, it's pretty close. Well, let's see what the actual time is, okay? So if I go and do, I'm going to do 1 over my 1866 times my 10, and that's going to get, I'm going to come out with my access time. I'm going to go to here, 1 over 2400 times my 13 equals my access time. Okay? So if I go and do that quick math to do my comparison of the two, I go 1 divided by 1866 times 10 equals 5.35. Okay, so we're going to say 5.3. Actually, I'm going to put 5.35 so we don't. Okay, so 5.35 is our nanoseconds thing. Okay, and then we'll go ahead and do the other one. 1 divided by 2400 times 13 equals 5.41. Which one's faster? This one's faster. Okay? If it had been 1 cast latency smaller, this one would have been faster. So you can't just look at this to say it's faster. Okay? This is an extreme example that has been massaged by Mr. Poole because it was not cast latency 13, which is why but I guarantee you, if we spent enough time looking for it, we would find this exact example. So the cast latency is a good comparison if they're the exact same number, but if they're not the exact same number, neither one of them gives you an exact comparison. The only way to get an exact comparison is just to do this. 1 over the speed times the cast latency with the decimal places, because it's always 5 point or 4 point something in seconds. Does the decimal places really matter? I had some of the, if I went and figured out the zeros and stuff, what happens if I was one decimal place off and this is 0.54 and then, does it really matter? No. This number is smaller than this number. Even if I was off and it was actually 0.5 nanoseconds instead of 5 nanoseconds. That's inconsequential as long as you do the same one on each one, right? Okay? But, so, they're pretty dang close. But this one is faster. And here's my example that I talked to him about this morning. This one is a normal speed that some motherboards take. This is a speed that almost no motherboard takes unless it's overclocked. Would I rather put this in overclocked slower than this one normal clocked slightly faster? I would rather have this one because when you overclock, you induce possible instability in your system, and some people, when they overclock, get more blue screens than other people. So if I was going to make this choice, if they came out to the exact same number, which these are pretty dang close, we're talking nanoseconds, okay, pretty darn close to the same speed, even if this one was faster by that amount, I would probably choose this one. Because if the choice was between not overclocking.
And wouldn't that one be most likely
overclocking?
Depending on companies, they'll be cheaper than,
Well, probably because I don't even know what HyperX is, so I don't know that as a company, so this probably is cheaper, but I don't know. Just because I know Corsair is usually more expensive. Actually, Crucial is usually more expensive. Corsair is usually pretty comparable to most other numbers. So I don't know the answer to that. Theoretically, yeah, if it's the exact same thing, this one is probably going to be listed cheaper than a 2400. Okay. But that's when I was talking access time, and that's in your reading, okay? If you go to your reading, it talks about figuring out the timing, and it wasn't straightforward like that. But down here, understanding RAM timing, right here. You can calculate the time the memory delays until it starts delivering data. The period of clock cycles needs to be calculated using the formula 1 minus whatever over. It's a little different way than I figured it out, but it's the same thing. Okay, you're inverting the frequency of the RAM or whatever the megahertz is, and then you actually multiply by the clock cycles. It doesn't say at all to figure that out. Okay, so that's when I was saying access time. Normally, I have a chance to talk about this before we get there, so that's why I didn't take off my points for it. Okay, I will for you two now. Aha, that's what you get. Get out your laptops and get working on your PowerPoints.